So let's take a look at a couple of examples here. We're going to use a shortcut. We want to find f prime of x. So we want to take the derivative of an integral. And the shortcut is simple. All you're going to do is step 1. What is 1? This is our shortcut. We are going to replace t with the x's. And step 2, we are going to apply the chain rule, because we're taking a derivative. So if I take a look at the first one here, again, I don't have to worry about the 3 down here. It's a constant. Its derivative is 0. So since I'm taking a derivative, I don't have to worry about that constant. So when I solve this one here, my rule says I just have to worry about the x. I'm going to replace each t with x. So this is going to become x plus 2 times the derivative of x. That's my chain rule right there. Because this chain, I'm subbing x into t. It's going inside of t. So what do we wind up with? X plus 2. Well, what's the derivative of x? Just 1. And there's our answer. Right like this. If we try the second one, so let's try the second one. This one's a little bit trickier. We're doing the x cubed. So again, I'm going to replace it with both t's into the dt. This is my chain rule part right there. That's our chain. So like this is my inside, that's my outside if you want to think about it. Because remember, this is in and this is out. It's our chain rule. So I'm taking the derivative of my inside and the derivative of my outside. That's an x cubed. So we're going to get x cubed plus 2 on the inside times, there's my derivative of my inside, times, now we've got to do the derivative of the outside, which is going to be the derivative of x cubed. Well, what's the derivative of x cubed? Just 3x squared. And I go times 3x squared. And there's our answer. So let's just take a look at a bunch more examples here. Ready? If we take a look at an example like number 1 here, go ahead and try this one. Ready? My rule says, I'm going to plug it on my inside, but then I also have to plug it into my outside. Again, that's a constant. I don't have to worry about that. So when I get my answer, we're going to get the 4th root of x times the derivative of x. Remember, inside, outside. So we get the square root of x. Well, what's the derivative of x? Just 1. There's my answer. Try number 2. Again, there's my x cubed right there. It's an x cubed. There we go. We're going to sub it into the inside. My inside is this function here. And there's my out. So it's our chain rule. So we can get 1 over 1 plus x cubed times the derivative of x cubed. And that just becomes 1 over 1 plus x cubed. But that's getting hard to read. Times 3x squared. And there's our answer. Very quick and easy. Very easy to do. Okay. Now again, I don't have to worry about the 2 because it's a constant. Because remember, we're really doing this. F of x cubed minus f of 2. But we're taking their derivatives. And that would become f prime of x cubed times 3x squared minus, and that is a constant, f of 2 gives me 0. And notice this is what we have. And you can still do it this way. F prime becomes my f, there's my derivative, f prime, 1 over 1 plus x cubed times the derivative of x cubed, which is our 3x squared right there. All right. Let's try number 3. Oh no, it looks nasty, but it's not too bad. Remember, this only works because I'm taking a derivative of an integral. And what these do is they cancel each other. The derivative of an integral cancels. So I should be left with this. But before they canceled, we did a substitution. We did do the first fundamental theorem. There's my inside and there's my outside. So we should just get the natural log of the sine of x times the derivative of the sine of x. So what's this? We get natural log sine of x. The derivative of sine cosine of x. Now be careful, we're not doing the first fundamental theorem here. We're not actually taking the antiderivative. We're just using what we know is going to happen if we were to take the derivative of it. So it's kind of like me saying this. If I'm going to take x, add 3, and then just subtract 3, well, I can anticipate this. I know that's just going to be x. It's like me saying, what is 100 plus 713 minus 713? Well, I know these are just going to cancel each other out, so I'm just left with the 100. That's, in essence, what we're doing here. I'm taking the derivative of an antiderivative. So if I found the antiderivative, if we found the antiderivative, all we're doing is taking that derivative again. I don't need to take the antiderivative because I know what's fundamentally what will happen. I'm going to wind up with our natural log back. Kind of wordy. I apologize for that. So let's take a look at the next example here, number 4. Same idea. But be careful. Notice this, not a constant this time. Oh no. So let's do this from the long way and you'll kind of get the idea. Ready? If we're going to get f of x squared minus f of x. Sorry. That was a terrible looking x. This is our first fundamental theorem. But remember, we now want to take the derivative of it. We're going to get f prime of x squared times 2x, don't forget your chain, minus f prime of x times 1. Notice in this case, this doesn't become 0. The second term doesn't become 0. So what we have to do is we have to plug both of these into our derivative. Remember, that's my derivative. So what am I going to do? Everywhere I see a t, I replace it with an x squared first. So, ready? This is going to become x squared squared minus 8 times x squared plus 11. Be careful. Don't forget your chain rule times 2x. Minus, now I'm going to replace each of my t's with just x. Ugh. So what does this become? X squared minus 8x plus 11 times 1. And there's our answer, but we can simplify it. This becomes x to the 4th minus 8x squared plus 11 times 2x minus, don't worry about that 1, x squared minus 8x plus 11. And there is our answer. We can simplify a little further if we wanted to distribute that, but we don't have to. So notice, this time because the second term does not cancel, we actually have to include it. So we're going to use our FTC, f of b minus f of a. So let's see if we can do it with this one with a shortcut. Well, the first one, what am I going to replace everything with? X squared. But then I'm going to replace it with the x as well. So if my first one, for the x squared, I mean, not write it that way, that can cause confusion. So my first one, this is just going to become negative 2x squared minus 2 times the derivative of x squared minus negative 2x minus 2 times the derivative of x. So remember, f of b minus f of a, where a doesn't become 0 here. So if I simplify it, we get negative 2x squared minus 2. Be careful. Chain rule, that's my chain rule, times 2x minus negative 2x minus 2. What's the derivative of x? Just 1. And there's our answer here. Those get ugly. Okay? Honestly, they don't get any ugly than that. Oh, no, except for this one. Let's try D. So take a minute. Try part D real quick. So what are we going to replace? First, we're going to replace with the cosine and then the 2x. Now notice the 2x is not going to go to 0 this time. So what are we going to do? We're going to replace them both inside and both on the outside. So this is going to become the square root of 1 plus cosine squared of x times the derivative of the cosine of x minus the square root of 1 plus 2x squared times the derivative of 2x. I'm going to clean this up a little bit. 1 plus cosine squared of x the derivative of cosine is negative sine of x minus the square root of 1 plus, that's just 4x squared, times the derivative of 2x is 2. And there we go. All right, so for 7, we're in luck. Notice that 32. That is a constant. So I am going to do the constant one the same way I did this one, okay? I'll show you what's going on here, okay? So if you want to verify another way to see how the constant becomes 0, again, my rule says this is just going to become the cosine of x squared times the derivative of x squared minus the cosine of 32 times the derivative of 32. You kind of see what's going to happen. This becomes cosine x squared times 2x minus the cosine of 32. Well, what's the derivative of 32? Just 0. So our final answer, 2x cosine squared of x. Whoops, cosine, that's terrible. Cosine of x squared. There we go. Right there. That's just 0 right here. All that's going to just become 0 for us. All right, try number 8 real quick and pause if you need to. Same thing. Now be careful. Not a constant. Not a constant. So, and I'm taking the derivative. I anticipate what's going to happen. This is going to become the sine of 2x squared times the derivative of 2x minus the sine of x squared times the derivative of x. Remember, just plug in the both. Over here, we get the sine of, and I can simplify that, 4x squared, makes it look nicer, times the derivative of 2x, which is 2, minus the sine of x squared, and what's the derivative of x? Just 1. And there's our answer. So, very easy to do. Honestly, we don't really get more complicated than these. We actually keep it really simple later on. But if you can do these, man, they're not too bad. So now, let's go to our favorite thing. Write the equation of a tangent line, or sometimes called the linearization. Now, for a tangent line, we need two things. We need a point, and we need a slope. So, to get the point, they're saying f of x is equal to this antiderivative at x equals pi. So what I want to do is I want to say, to get the point, we are going to say f of pi is the integral from 0 to pi over 3 of sine of t dt. So I have to evaluate this. So we can use our antiderivative. This is our FTC step. The antiderivative sign is negative cosine. So that's not working. Negative cosine of t from 0 to pi over 3. When we evaluate this with the FTC, we're going to get f of pi over 3 minus f naught. This is a tough question right here. That's going to give us negative cosine pi over 3 minus, or in this case, a negative cosine of 0. So if I simplify that, the cosine of pi over 1/2, so that becomes a negative 1/2 plus 1. That's just because cosine of 0 is 1. So that becomes 1/2. So our point becomes pi 1/2. Now to get the slope, remember the slope is the derivative. It's f prime of x. So let's take a look here. F prime of x would be given by the derivative of this. 0 to x over 3 sine of t dt, which by our new rule says this is just going to be the sine of x over 3 times the derivative of x over 3. Remember, this is a constant. It became a 0 for us. Sorry. And this just becomes 1/3 sine x over 3. And if I do this, we get 1/3. Now, we're going to now let x equal pi, and we get the sine of pi over 3, which is 1/3 times the sine of pi over 3, root 3 over 2, so we get root 3 over 6. Ooh, that's nasty. So there's my point, and there's my slope. This is as nasty as they come. Now the last thing we have to do, and I ran out of room here, is to write our tangent line. To write a tangent line, we use the same formula all the time. Y minus y1 equals mx minus x1. So here's our point, x1, y1. So we get y minus 1/2 equals m, which we said was root 3 over 6, x minus, in this case, pi. And there's our tangent line. Okay, so I hope you enjoyed the video, and I'll see you all later.